Hi there, my name's Simon Levette. I'm the Centre Manager for the ABC Assessment Centre, and today we're going to be demonstrating how to install a non-combustible cavity tray to manufacturer specifications, as well as a traditional site-formed cavity tray using flexible DPC roll. And with me today, we've got Ian Mitchell, who's going to help me with the practical aspect of today's install. So, before we start, I'm just going to ask him to introduce himself and talk a little bit about his experience within the construction industry. So, over to you, Ian.
Thank you, Simon. So I bring 30 years experience to this training video today. I had a 3-year apprenticeship as a bricklayer, 17 years gaining experience on site, onto site manager's role, and then contracts manager. So bringing here 30 odd years experience. Thank you very much, Simon.
Great, well, absolutely fantastic to have you here to help, Ian. Let's just remind ourselves what DPCs and cavity trays are, where they're found, and their different applications. DPC stands for damp-proof course, and it's added to both skins of masonry to combat the effects of rising damp or capillary action. DPCs are found at ground level or splash course, which is usually 150 millimeters as a minimum above the external ground level, and also in other locations such as at the top of parapet walls and underneath sills and coping stones. Stepped cavity trays are also found where there is a change in ground level around the perimeter of a building, and they can also be found in pitched roofs where there are junctions between the roof and the cavity wall. They should be installed wherever there is an interruption to the cavity, for example where there is an air brick, a lintel, a cavity barrier, or a masonry support angle. Traditionally, cavity trays have been formed from the same material as DPC, which is a flexible ruberoid roll, and then bedded into the blockwork and the brickwork. However, due to changes in legislation regarding non-combustibility and the need to only use non-combustible materials over 18 meters in height, we need to have a new system in place, which is where our non-combustible cavity trays come into their own. Hence, the idea of this training video is to provide you with the knowledge and the practical ability to install both. The ABC Assessment Centre's Specialist DPC Cloak Systems short course that accompanies this video goes into more detail about the different types of material that we can use as a DPC, the different types of application of cavity trays when on site, the differences between site-formed and prefabricated units, and also how that ties in with building regulations and fire regulations. Without further ado, let's go on to look at some health and safety considerations. Some health and safety considerations to be aware of when fitting the different types of cavity tray system. First of all, take extra care when using cutting equipment, for example, retractable knives when cutting DPC, and do so on a hard and flat surface and away from other operatives. Most non-combustible cavity tray systems require a mechanical fix either into the blockwork behind or, for example, tech screwing into a steel frame structure, and so you're going to have to use power tools. These power tools should always be PURE registered, they should be visually inspected prior to use for suitability, and you should also monitor for HAVs over the course of the working day. Whether your cavity tray is stainless steel or flexible DPC, in both cases we're bedding it into mortar. Now, mortar, as we know, is a substance hazardous to health, so we should not get it on our skin, as that could cause cement burns and potentially dermatitis if the exposure is severe enough. So always wear the correct PPE and be extra careful when using mortar. As always, keep a nice, clean and tidy work area and eliminate any objects that could lead to slips, trips and falls. For all of these considerations, plus anything task-specific, check the RAMS document prior to undertaking any task. Before we go any further in this video, it's worth pointing out the personal protective equipment, or PPE, that you must wear when on site, because without wearing this personal protective equipment, you cannot even get to the point where you're doing the installation, similar to that we're doing on the video today. So, what do I mean by PPE? Well, it's a 5-point PPE. And myself and Ian here have the correct 5-point PPE, which consists of hard hat, glasses, high-vis vest, gloves, and steel toe-cap boots. Remember, there are some jobs on site or some tasks that require additional PPE, and information related to these can all be found in the RAMS document. Okay, so we're going to look now over to the equipment table. We're going to have a look at the materials required and equipment required for the installation of this specialist DPC cloak systems. On the one hand, we have our non-combustible cavity tray and related equipment. And on the other side, we have our traditional DPC performing normal site formed cavity trays. You'll notice here on this side with the non-combustible cavity tray, it's formed of several different sections. Some are special sections, for example, stop ends and corners. Okay, in this case, you have an internal corner. Obviously, external corners are available as well. And it's important to note that they have a base tray, which sits on top of the brickwork, and you have an upstand. Now, the upstand tray goes like this. Here we have a drill with a hammer function for very resistant blocks or masonry products and concrete, and the fixings here for masonry. Okay, here we have plugs and screws, and that's going to fix into the system that we've got today on the training rigs. So that's the non-combustible system. Now we'll talk about what we call traditional DPC, or a traditional cavity tray formation. So you have your flexible roll of DPC. In this case, we've got 30 meters worth of 450 millimeter width DPC. And if you have any joins between the DPC sections, or rather the cavity tray sections, you bond using jointing tape. Okay, in this case, black jointing tape to match the color of the cavity tray. If cutting is required, you'll need to use a Stanley knife or a retractable knife or similar. And finally, whenever you're building one course above either traditional DPC or non-combustible cavity tray, you obviously need to incorporate weep vents. Why do we use a non-combustible cavity tray, and why do we use the traditional DPC? Well, the difference is essentially that for buildings above 18 meters, you can use non-combustible, whereas you cannot use traditional DPC. And this is purely to do with the fire ratings. This system, which is the ACS G tray, is A1 non-combustible, meaning you can build to unlimited height, hence why it's used in a lot of high-rise buildings. It's used a lot commercially, whereas this, you might see more residential and low-rise buildings. Now that we've done our PPE check and our equipment check, it's time to move on to stage 1 of the install process for the non-combustible cavity tray system, and that is setting out. As with everything in bricklaying, preparation is absolutely vital, and it's vital that you get the preparation absolutely right. As with every other non-combustible cavity tray system, all the components are made off-site, palletised and then delivered to site with drawings and instructions for the on-site operatives to install to those specifications. It's really important to note that you should always start the setting out process, as well as the install, from corners before adding the horizontal mid-run trays. Ian is now dry bonding the brickwork to form the external corner up to the left stop end, adjusting it to fit and remembering to place a weep hole in the perp joint at the end of the system. On the left and right hand side of the system, where you have the lip up on each side, known as stop ends, you'll notice that Ian is setting them out directly above the perp joint on the first course of brickwork, in order to maintain and not interrupt the bond pattern. Now that the corners and stop ends are set out correctly, Ian is lifting in the horizontal base trays lapped as per the manufacturer's specifications. Ian is now making some final adjustments to the eventual positioning of the trays, making sure they sit on top of the preformed stop ends and corner components. As you see, Ian is starting at the left corner, the external corner, and is laying a fresh bed of mortar underneath the bottom tray. He is now lowering the corner and stop end units onto the mortar and tapping them to bed them in nice and firmly. By way of double checking the components haven't slipped out of place since the set out, it's good practice to do exactly what Ian's doing here. Now Ian is laying a bed of mortar on top of the tray and laying 2 bricks to form the external corner, as well as a weep vent directly above the perp joint 2 courses below. Now Ian is repeating the same process, except he is bedding in the internal corner this time. It's now time to bed in the run of straight trays between the 2 corners. To complete the Z section that's been specified, Ian is now bedding in firstly the right hand stop end, and once in place and weighted down temporarily, then the remaining long horizontal run of bottom trays, making sure the front edge of the trays does not oversail the front of the brickwork. As you can see, the horizontal trays overlap the internal corner, where Ian is now laying a bed of mortar and adding the 2 corner bricks. This will allow him to level through and lay runs in both directions. After laying a brick and the weep hole at the end of the section of the right hand stop end cavity tray, we now have the entire horizontal section to lay to a line as normal, including normal buttering up technique and laying on a fresh bed of mortar on top of the horizontal tray. You will notice that weep vents are being inserted between perp joints every 2 bricks horizontally. This is standard procedure when building on top of a cavity tray, whether it be a traditional cavity tray or in this case, a non-combustible cavity tray. Once the third course of brickwork is entirely done, care must be taken to make sure that all snots are taken and removed from behind the brickwork, i.e. on the bed of the tray, and also that all weep vents are not congested with mortar and that there is the potential for moisture egress from the cavity. Here you can see Ian presenting the top tray of the cavity tray detail up to the inner leaf of blockwork. Once your fixing points into the blockwork have been decided and marked out, it's time to drill into the inner leaf, allowing you to install plugs and drill in the specified fixings in at least 2 locations per tray. Note that there must be a clear 20mm distance between the bottom of the top shelf and the bottom angle, which is the bottom tray of the non-combustible system. Once you've mechanically fixed all the corresponding top trays back to the blockwork, lapping each one by at least 150mm and maintaining a gap between the components to eliminate thermal bridging, you've successfully installed your non-combustible cavity tray system. For many brickies working with smaller builders or on house building sites, using a flexible DPC roll to achieve a cavity tray is like the bread and butter. It's something you would do every single day. To summarise what Ian's going to do, he's going to create a cavity tray from DPC roll that has a 225mm upstand, i.e. the height of one block. He's going to achieve this by measuring out the DPC, cutting, taping, lapping, and then bedding in the DPC, and then he's going to lay his brickwork to a line, incorporating weep holes as he goes. So let's start at the beginning. As you can see, Ian has simulated the end of another section of pre-cut DPC, so is now measuring the length of the material he needs to complete the tray to fit it up to the steel on the left-hand side, taking into account the amount he'll have to lap the existing piece. He is now using a retractable knife to safely make the cut, and his next job is to offer it up to the wall and temporarily weigh it down with a brick in this set out position. Now Ian is measuring to see if he's left a compliant lap, which should be at least 100mm, but ideally more. Once measured, peel back the overlapping membrane and apply a length of double-sided jointing tape to the bottom DPC, as Ian is doing now. This is quite a fiddly process, as this stuff is very sticky indeed, but over time you'll get used to it. Talking of fiddly processes, there's a skill in taping the lengths of DPC together without them folding up or sticking incorrectly. You'll need to lap it straight and create a tight seal between the two pieces with no air gaps, otherwise the cavity tray will not be effective at its job. Now you see that Ian is laying a half bed of mortar all the way along our section of brickwork. This is deliberate because the other half bed is going to be on the top of the cavity tray. Once done, it's just a case of bringing the cavity tray down, pulling it taut to the front edge of the brickwork and, if needs be, bedding it in with a trowel for good measure. From here on in, the remainder of the install procedure is very similar to what we've just seen. We need to set up our corners, set up a string line, add a bed of mortar, and lay to that line, remembering to insert weep holes every 2 perp joints. The main difference here is that we need to manufacture our own stop end by turning up the DPC at each side. If this were at the end of a lintel, for example, it would stop any moisture running off the end of the tray and back into the cavity. This way, we're directing water outwards and not inwards. The last thing to do, besides making sure all excess mortar is removed from the cavity tray, is to permanently hold the top part of the tray in place by bedding it into the blockwork. Therefore, as you see, Ian is laying the final course of blocks, as he would any other course, to finish off this install demonstration. As you can see from the finished result, Ian can be very proud of his work. This cavity tray would be effective at deflecting any moisture out of the cavity via the weep holes, and now it would be a case of replicating this around the entire building to the same high standard. As you see, we've now finished the installation of our A1 rated non-combustible cavity tray system, and also our traditional cavity tray, Cloak, using a flexible DPC roll. But what I wanted to do before finishing is just get a couple of words from Ian and just get some top tips for this kind of installation. So Ian, if you wouldn't mind sharing some tips.
Thank you, Simon. Tips for installing DPC. Let's check the materials are okay. They're not punctured or any damage done to them. They've been stored properly. The drawings tell you exactly where to install them. Are the weep holes in the right position? Are they clean? Is the cavity tray clean? Techniques while installing a DPC or building the cavity would be cavity battens, which catches the mortar droppings from each skin. Remove that on each lift and then clean it off. Following these procedures, everything should be fine. So thank you very much, Simon.
Excellent, thank you very much. And the traditional form would be a bricklayer's sort of bread and butter. As Ian said, it's something that you'll have to do many, many times over the course of your career. But the newer aspect and the newer innovation of the non-combustible cavity tray is definitely a great competency to have, as larger subbies are taking on this kind of work all the time. And having that competency is going to be great for your employability. So anyway, the last thing to say is a big thank you from Ian and myself for watching today's video, and we hope to see you again very soon for another install video.